What is an architecture blueprint? An architecture blueprint is the first step in designing your data platform. It is similar to the architectural blueprint created for constructing residential or any commercial property. In the context of data and analytics, an architectural blueprint represents the various components required to implement an end to end data platform. It helps define the core components and their interdependencies and shows how the data will flow between them. Data architects use this approach to represent the final architecture diagram along with the chosen technology stack for implementing the data platform. In simple words, the architecture blueprint is the final architecture diagram that will be used to create the high level design and eventually to implement the data platform. So, why do you need it? An architecture blueprint helps you understand the end state or the target state that you want to achieve. It also helps you understand the final tech stack that you plan to use for implementing your data platform. Once the architecture blueprint is finalized, you can use it as an input for creating the high level design document. It will also help you establish the design principles and accordingly design various data management processes. Architecture blueprints can often help you identify any major tech blockers that can impact the platform design. What are the key design considerations for creating an architecture blueprint? Let's try to understand this now. To architect any platform, you must first understand its requirements and its expectations. Some examples include ingestion frequency, reporting frequency, latency, and associated SLAs. You will also have to understand the different data types that the platform is expected to support. Do you want to handle structured data? Or also there is a requirement to handle the unstructured data. Are there any BI use cases? Or do you also have AI ML workloads? Understand if there is an approved or any preferred tech stack. Some organizations might want to use only cloud native technologies, while others might have some constraint to use only on premise setups. Understand these and accordingly design the solution. All these are important design considerations. But these are just few of them. There can be many more depending on your use cases. Study all of these carefully before you start architecting your solution. Please use this slide only as a guidance and make changes as per your requirements. The next step is to select the architecture. Selecting the architecture for implementing your data platform is one of the most critical design decisions. There are various architectures that you can consider. Some of these choices are a cloud data warehouse for supporting various BI use cases, or a cloud data lake like ADLS, AWS S3 for supporting AIML use cases. You can also create a combination of using a data lake and a data warehouse to support BI as well as AI workloads. Or finally, you can consider implementing a lakehouse architecture that can support all of these data types and all data workloads. If you want more details about lakehouse architecture, you can go ahead and read my book, Practical Lakehouse Architecture. I'll provide the link in the description. There can be other options also, like combining these architectural patterns or using your existing platform in combination with this new platform as well. You will have to spend some good amount of effort to finalize the pattern. Next up is to select the tech stack. Selecting a tech stack is not easy. There are many tools and technologies available in the market that can provide similar features for implementing your data platform. Some of the design decisions that you will have to make are which cloud platform to use. Do you want to use AWS or Azure or Google Cloud Platform? Or do you want to use any of the third party platforms like Databricks or Snowflake? Next is to select the services. Which services you want to consider? You can use AWS Glue or also Amazon EMR for processing in AWS. If you are using Azure, you can use Synapse Analytics or Fabric. Every platform has multiple services that you can explore. Fabric on its own is a completely different SaaS platform. Check how these services integrate with each other, as well as how do they integrate with the other services like monitoring, orchestration, governance, etc. Think holistically when selecting the tech stack. Evaluate each of these carefully, study their pros and cons, and understand the performance and cost aspects. Since this video explains an architectural blueprint, I'll not get into more details related to the tech choices. You can connect with me on Topmate. I provided the link in the description to discuss these topics in further details. The last step is to create the actual architecture diagram or the blueprint. You can start with very simple diagram with the core building blocks as shown in this slide. You can then start adding the tech stack against these building blocks. Start with source systems like databases, files, real-time messaging system like Kafka, if at all that is one of your source systems. Check the best options for ingesting data from these sources. It can be an ingestion framework or an ETL tool. Next, map the storage options, whether you want to use a data lake or a warehouse, depending obviously on the selected architecture. Mention the data processing and consumption technologies. Now, processing can be done in Spark, it can be done in SQL or any other engine. There are other cloud services also, like discussed earlier. If you are into AWS, you can use EMR or Athena. Look for the target workloads. This can be BI, AI, interactive queries, or any downstream applications. Also, remember to note the services for implementing other features like governance, security, monitoring, logging, orchestration, and other DevOps activities. You'll need multiple iterations to create the blueprint drafts. Post that, there will be multiple reviews to finalize it. And finally, there will be multiple presentations to relevant stakeholders before locking it down. In all this process, be very patient, be curious, and enjoy the process. Well, if all this seems too easy, just hold on. Architecting a data platform is not just creating the block diagrams or the architectural blueprint. A lot goes into the design process. You have to explore, understand, and validate multiple things. Some of the common mistakes that we all make are listed below. First, not exploring different architectural patterns. As mentioned earlier, selecting the architecture is the most critical step. Do proper R&D, understand the requirements, and consider various design considerations before choosing the architecture. Same applies for the tech stack also. Selecting a tech stack without doing a POC or a tech feasibility study can lead to severe issues later, delaying the delivery timelines. Another common mistake is not being practical. We often make design decisions based on only the product documentation that we read, or after reading some of the tech blogs, or after watching some of the YouTube videos. Please don't do this. Do your own study. Remember, every use case is different, every project is unique. Use all these things as a reference material and customize your solution as per your needs. Also, don't just follow what has been done previously. Be bold and explore new things. There will be always some new tools and technologies that can suit your requirements. Explore them. Finally, look for future proofing your architecture. Just don't look at the current requirements, but also think about the future requirements. So, what are the next steps? Now that you have created the final architectural blueprint and you have got the sign-offs, and now that everyone is happy, there are multiple next steps that you will have to perform. A lot is yet to be done. This is just the start. Start working on high level design. It's the only document that can help your developers to understand the architect's thought process and the overall vision. Data modelers will have to work on the data modeling aspects for organizing the data into organized tables. Explore which modeling approach you want to use. That's another important activity and a very complex puzzle to solve. Also create the source to target mapping documents. These will help developers to create the transform jobs for loading data in the higher storage layers. Each of this activity needs dedicated time and expertise. Maybe I'll try to cover all of these in some of my future videos. Thanks for watching, and do let me know if you would like to know more such stuff and would like to go through more such videos based on any of the topic related to data architecture, data engineering, data management. Thanks for watching.